It's pretty wild when you think about it, going from a single fertilized egg to a whole tiny human in just 9 months. It's got to be one of the most complex, high-speed construction projects in the universe. So today, we're going to look at the blueprint for that project and the absolutely critical supply chain that makes it all happen, the first 1,000 days.
Okay, let's just jump right in. Look at this progression from a tiny little blastocyst to a 20-week fetus. Every single step of this process needs a massive, perfectly timed delivery of materials. And if that supply chain breaks down, even for a little while, the whole project could be in jeopardy.
So first, let's just get a sense of the scale here. Fetal growth is what scientists call a highly anabolic process. And all that really means is it's all about building things up. It's just consuming a tremendous amount of energy and raw materials to construct everything, tissues, organs, whole systems, right from scratch.
So how does the body even handle a project this massive? Well, to manage this incredible demand, the mother's body basically undergoes a complete redesign of its own internal systems. It's a master plan, really. And it's executed with this breathtaking precision to make sure that new construction is priority number one.
What's so fascinating here is how this all works. You can think of it like a hormonal symphony. You've got rising levels of estrogen, progesterone, and something called human placental lactogen, or HPL for short. These act like the conductors, and they completely rewrite the mother's metabolic rule book for the whole pregnancy.
So think of each of these hormones as a dedicated site manager on the construction project. Estrogen, it's in charge of stockpiling materials, building up fat stores for later. Progesterone helps lock those nutrients away. And HPL, it does something really clever. It makes the mother's body just a little bit insulin resistant. It's basically telling her cells, hey, back off the glucose. That's for the fetus.
And right at the heart of everything is the placenta. Now, it's not just some passive tube. It's an incredibly active smart hub. It actively pulls vital nutrients from the mother's blood. It stores them to smooth out any supply issues, and it even changes them into forms the fetus can use more easily. It is the logistics center for the entire operation.
Okay, so the logistics are all sorted out. Now let's talk about the specific materials, the essential building blocks. We're going to look at a specialist team of micronutrients, and each one has a critical, non-negotiable job to do.
First up is folate. We can call this one the neural architect. Its main job is to help build DNA, which is, the actual blueprint for every single new cell. And during pregnancy, with cells dividing at an unbelievable rate, the demand for folate just skyrockets.
And this shows us folate's most time-sensitive job perfectly, closing the neural tube. This little structure eventually becomes the brain and the spinal cord. And here's the thing. It forms and closes super early in pregnancy, a lot of times before a woman even realizes she's pregnant. This is exactly why you hear so much about the importance of things like prenatal vitamins with folic acid.
So the really crucial point here is all about the timing. There is a very, very narrow window for this step to happen the right way. A short-term shortage of this one building block, right during that critical period, can lead to permanent, irreversible defects in the baby's central nervous system.
All right, next on our team is iron, the oxygen supplier. Iron is the absolute core of hemoglobin. That's the molecule in our red blood cells that carries oxygen. During pregnancy, the mother's blood volume expands like crazy. And on top of that, the fetus has to build its own entire blood supply. This just creates a massive, massive demand for iron.
The body is so smart about this. The placenta is literally covered in these specialized receptors that act like magnets, actively pulling iron from the mother's circulation and shipping it over to the fetus. It makes sure that this vital supply line is always prioritized. But if that supply of iron starts running low, the consequences are pretty direct. The mother can develop anemia, and the oxygen supply to the fetus can get compromised, which can impact development. The construction project literally starts to run out of breath.
And finally, let's bring in our structural engineer, calcium. Calcium teams up with phosphorus to form these things called hydroxyapatite crystals. This is the mineral matrix that gives bones and teeth their strength. It's basically the concrete and steel of this whole building project. Now, the demand for calcium goes through the roof in the third trimester. This is when the fetal skeleton is rapidly hardening up. And to meet this demand, the mother's body does something amazing. It dramatically boosts how efficiently it absorbs calcium from her food, pulling in way more than usual to send to the fetus.
But what if what she's eating isn't enough to meet that demand?
Well, the body has a backup plan, but it's a costly one. It will actually start to pull calcium from the mother's own bones, basically treating her skeleton like a reserve bank to make sure the fetus gets what it needs.
So, we've seen the ideal plan, right? The perfect construction project inside the womb, where the supply chain is running smoothly. But the project isn't over at birth. What happens during those critical first few years if the fundamental building materials, we're talking protein and energy, are missing? What happens when the blueprint fails?
And this brings us to something called protein-energy malnutrition. It's a condition with two very distinct and often really misunderstood faces that pop up from different kinds of supply failures in early childhood.
Just take a second and look closely at these two images. On the left, you see a child with kwashiorkor. See the swollen belly and puffy limbs? That's called edema. Now on the right, you see a child with marasmus, with really severe muscle wasting. They look so different, but they're both forms of severe malnutrition. So what's going on here?
This table really breaks it down perfectly. Kwashiorkor is mostly a protein deficiency. Marasmus, on the other hand, is a deficiency of both protein and total energy. And that one difference is why you see things like the swelling and fatty liver in kwashiorkor, but that severe wasting is the main feature of marasmus. So the core difference really boils down to one key player, insulin. In kwashiorkor, there's usually enough energy coming from carbs, so insulin levels stay pretty high. But without protein, the liver can't make this important protein called albumin, which keeps fluid inside our blood vessels. So that fluid leaks out into the tissues and causes all that swelling. In marasmus, though, there's no energy or protein, so insulin levels just plummet. The body goes into full-on survival mode, breaking down its own muscle and fat for fuel. It's a total energy crisis.
And all of this brings us right back to our central theme. The nutrition that a baby gets during pregnancy and in those first 2 years of life, it's not just about short-term growth. It's about laying down a lifelong foundation for health, for metabolism, for cognitive potential, for everything.
The entire architecture of a human being is set up in this incredibly short and critical window. The consequences of a faulty supply chain, whether it's in the womb or in early childhood, they don't just go away. They can echo for an entire lifetime. And that really leaves us with a critical question to think about: what are our responsibilities to make sure that every single one of these new construction projects gets all the materials it needs to succeed?